should we, to clarify, be putting the approximate instead of the equal sign for 32 yards?
You mean here?
Yes.
No.
Like right before the $32.
No, these two are approximate. This equals this. This equals. I'm telling you that this is approximately this. So maybe I should write them again. So delta y is 32.0005 is approximately 32. That's what I'm saying.
I guess if I were saying, depending on how you might ask them quiz or a test, if we use the first one.
Let me give you an example before you ask the question. However, I'm jumping because this is basically a topic from 3.10. But let's look at an example because this idea is intriguing and it's extremely useful. And you'll see in a moment. And we'll come back to this again. But since we're here, we're not. So let's say the radius of a circular disk, because I mentioned that, or we can look at anything else. So the radius of a circular disk is given as 24 centimeters with a maximum error in measurement of 0.2. So what is 24? What is 0.2? The error, right? It could be minus 0.2 or plus 0.2, it doesn't matter. Okay, use differentials to estimate the maximum error in the calculated area of the disk. So the area is the function. So we know that for now, don't forget what you want to ask, but maybe this, after we do this, look at this problem, maybe that's clear or better. So this is 34 on page 255. So we have x equals 24 centimeters. We have the x, which is 0.2, and they want to find the maximum error in the calculated area of the disk. Max error in area. I can't determine anything about a function if I don't have the function. So what is the area of a disk? What does it equal to? Yes. But since we are denoting the radius by x, I'm going to use x with your permission. So we know that delta A is approximately dA. Correct? So I could determine delta A by saying, so let me put A of x. How do I determine this? It's A of 24, let's say this is positive, 24.2 minus A of 24. This is this side. Agreed? But what about this side? This side is, by definition, we have to remember this, it's A prime of x times dx. And this is, let's find A prime of x, 2 pi x. Good. So then this side will be 2 times pi times 24 multiplied by 0.2. Which do you prefer? This simple product or plugging in the original function, 24.2, and subtracting when you plug in 24? You can say it's not a big deal, and I would have to agree that it's not a big deal. But this, I can even tell you what it is, right? Because I multiply by 0.4, or let's say, so this is 48, 9.8 pi. I'm done. But here I can't do that. So let's see what happens. So let's determine all these numbers. So I have 24, so pi, I'm going to put pi outside, I'm waiting, it's a constant. So pi, in parentheses, 24.2 squared. And then minus 24 squared, and this is the exact. The other one will be 2 times pi times 24 times 0.2, and this is what the derivative gives, the differential. So this is a prime of x dx, and this is the exact. And I think that they are close enough. Yes, please.
So
Okay.
in a test or a quiz or something like that, when we come across these kinds of problems, we have to write both? Or can we just-
No, the problem will tell you exactly what. So in this case, it says use differentials. It does not say to determine the exact. It says use differentials. And these are the differentials. Sorry. So it says use differentials. This is the differential of x, the minor error in x, and this is the differential of y, the minor error in y using the derivative. It doesn't say to calculate.
Yeah,
So-
I guess that's the difference there, right? Like it's,
Yes.
I can see it says estimate, so I would just imagine.
Yes.
The appropriate way for us to
Yes.
answer in this case would be the approximate symbol, and if you said calculate, you'd be doing the equal symbol. So that's
Correct.
Exactly.
Correct. And it also says the indicator is differentials, the word differentials. The difference calculated with the derivative. So this is 30.1594, and the exact is 30.2849. So this is an estimate of that. It's a quick estimate. Okay. There is also part B. We don't have to do it now because we can go back to 3.7. What is the relative error and what is the percentage error? You want to finish this one with the relative error and percentage error, or you can leave it for, no, okay, some other time. When we get to it, that's fine. I agree. Okay, back to 3.7. Is this clear now? Is it better? But remember, this is the key definition. F of x plus dx is approximately f of x plus f prime of x dx. So please carve this in stone. And we know how we got it. We got it from delta y approximately dy. Okay, so back to, we looked at the motion problem. We looked at the marginal cost problem. And now I would like to look at a tank of with gallons of water and so on and so forth. So let's read that problem. Okay, so if a tank holds 5,000 gallons of water, which drains from the bottom of the tank in 40 minutes, what does that mean, it drains?
0 gallons.
0 gallons after 40 minutes, exactly, perfect. Then Torricelli's law gives the volume V of water remaining in the tank after t minutes. So at t equals 0, at t equals 1, 5, 10, 15, 20, 30, 40. This is the formula, this is the function. I really don't like the fact that they don't put V of t. It's V of t, it's not just V. Find the rate at which water is draining from the tank after 5, 10, 20, 40. At what time is the water flowing out the fastest, the slowest, and summarize your findings. So if I'm asked to find the rate at which the water is draining, of course. So let's copy the function. It's V of t. And then I would like after that to look at one more motion problem. So 18. You're too patient. 18 on page 234. If a tank holds 5,000, okay, so it's V of t, 5,000, 1 minus, I think it's 1 over 40 t, everything squared, and t is in the interval 0, 40. Find the rate at which the water is draining from the tank after 5, 10, 20, 40. At what time is the water flowing out the fastest and the slowest, and summarize your findings. Okay, so let's find V prime of t. We bring down 2, so it's 10,000. 1 minus 1 over 40t raised to 2 minus 1 times the inner function prime, which is -1 over 40. Agreed? Since the volume decreases in the tank, what do you expect all these rates to be? Positive or negative? Correct. Because the volume is decreasing. And of course, I'll simplify, and I'll divide 1,000 by -4, and I have -250. 1 minus 1 over 40t. Okay. I could rearrange it and put it correctly in descending order. So I have 25 over 4t and minus 250. 250 times 1 over 40 is 25 over 4. Both are negative, so the answer is positive. And then I distribute. I'm going to put this in the graphing calculator again. So I have 25 over 4. You can remove everything. We're done with that problem. So we have 25. I always put it in parentheses. Please put it in parentheses. X and minus 250. And then we go to second and table and plug in 0, 5, 10, 20, 40. So I copy. At 0, -250. At 5, -218.8, -187.5, -125, and 0. I did not write any measurement unit. So what is the measurement unit? Gallons per volume? Yes. Per minute. So this is the measurement unit for all those numbers. -250, -218.8, -187.5, -125. I didn't look at the decimal part. I'm happy with this. So where is the rate the highest? Of course, when there is a lot of pressure inside, right? So where is the highest rate? Right. And where is the lowest rate? Of course. And we summarized our findings. Any questions? The rest applications of chemistry and so on and so forth, you're gonna talk about them when you get to that particular topic in your chemistry class. They will present that specific ideas. But now I would like to also look at this. It's another important topic. So let's read. It's a long problem. It has from A through I questions. So you will choose a function, any function you want. Find the velocity. What is the velocity after 3 seconds? What is the particle at rest? Blah, 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 blah. So let's choose a function. And then we'll go through all those steps. 1, 2, 3. Which one? 1. 1 it is. So we have f of t equals t to the third minus 12t squared plus 36t, and this is problem 1 on page 233. Good. First question. Let me read it from the beginning. A particle moves according to the law of motion. So this is motion. Where t is measured in seconds and s in feet. T in seconds, f of t, in other words, in feet. And of course, t is greater than or equal to 0. Okay. Find the velocity at time t. That's part A. How do I determine v of t? Yes, I have to find f prime of t. Can anyone give us f prime of t? 3t squared minus 24t plus, excellent, part B. What is the velocity after 3 seconds? How do I determine the velocity after 3 seconds? V of 3, very good. So it's 3 times 9 minus 24 times 3 and plus 36. I'm lazy. So this is 18 minus 24 times 3 and plus 36. I got negative 18. Measurement unit, please. Yes. This does not mean that the particle has a negative speed. It only means that the particle, when it moves to the right, it's in the positive direction. When the particle comes back, it's in the negative direction. That's all it means. It only gives the direction. From home to work and the opposite direction back to home. Part C. When is the particle at rest? When is your car in the parking lot at rest? When is, right, we certainly hope that. So the particle is at rest when the velocity is 0. Okay, so 3t squared minus 24t plus 36 is 0. What am I trying to determine now? Yes, so what would be the first step? The first step is to identify the type of equation. The equation is quadratic. Next, how many solutions will I have to write? 2 solutions. Excellent. So we will have to divide both sides by 3. Not have to, but you know me already. I cannot divide by t, but I can divide by 3 to simplify. So I have t squared minus 8t and plus 12. And this is really helpful because now I see that I don't have to go to the quadratic formula. I can easily determine by factoring the solutions. So what do I get in parentheses? Very good. So we have 2 options for t, and they are and 6. So the particle is at rest. After 2 seconds, when it starts moving, and after 6 seconds from the moment it starts moving. This was part C. Part D. When is the particle moving in the positive direction? Okay. So let's take a look at t. 0 to infinity. T equals 2. V prime. I didn't mean to write v prime. I meant to write f prime. But since I wrote v prime, I'm going to just delete the derivative. So v of t is 0 at 2 and also 0 at 6. Okay. So Can you please plug in 0 for me and tell me the sign between 0 and 2 for V? Just the sign. Good. Can you please plug in, let's say, 3 and give me the sign? 27, yes. 27 plus 36 is 63. But negative 24 times 3 is more than 63. So this is indeed negative. And what if I plug in 10? So this is 300 minus 240 plus 36, obviously positive. And now we know when is the particle moving in the positive direction, whenever its velocity is positive, and when it's moving in the negative direction, whenever its derivative is negative. The particle is moving in the positive direction when the velocity is positive, and in the negative direction when the velocity is negative. So I will say between, positive, let's say just say positive direction for t in the interval 0 to union 6 to infinity, and negative direction for t where? When t is in between 2 and 6. Do not use brackets at any point. Although the reason I don't use brackets is because at 2 and 6 and 0, it's 0. So it doesn't have a sign. So that's why I recommend not using brackets. Okay, next. Find the total distance traveled during the first 8 seconds. Any questions on part D? So t in between 0 and 8. In other words, 8 should be somewhere here. F of t. I don't really need this table other than finding the values, and I'll explain what we do next. So let's put in f function. We only have, I think, the derivative in there. No, we don't have any. Okay, so let's put the function in, t cubed minus 12t squared. Plus 36t. And let's go and evaluate. I have to let it continue because otherwise it freezes. Okay, so we want 0, 2, 6, and 8. 0, 2, 6, and 8. Okay, so at 0 is 0, at 2 is 32, at 6 is 0, and at 8 is 32. Okay. Any questions so far? Okay. Good. So between 0 and 2, the particle is moving in the positive direction. Total distance will be the absolute value of s of 2 minus s of 0 plus. Between 2 and 6 is moving in the negative direction plus the absolute value of s of 6 minus s of 2 plus. Between 6 and 8 is moving in the positive direction. The absolute value of s of 8 minus s of 6. Why do we put absolute values? It's because I have to add distance no matter what the particle is doing. Meaning, if the particle is moving in the positive direction, I'm adding distance. If the particle is moving in the negative direction, I still have to add distance. If the particle is going back, I still have to add distance. So the distance is always added no matter which direction the particle is going. So all I have to do now is perform these calculations. 32 minus 0, the absolute value is 32, plus 0 minus 32, 0 minus 32, that's negative 32, but the absolute value is 32. And then 32 minus 0, it's 32. The absolute value is 32. So this is 96. Measurement unit. Careful. Feet. That's it. Total distance, feet. Okay, it says draw a diagram like in figure 2. Okay, so let's look at what kind of diagram I will plot. So part F. So the particle starts here at t equals 0. It goes in the positive direction, 32 feet, for 2 seconds. And then it turns around, going back 32, and then goes back. So this is t equals 6, and this is t equals 8. So 32 feet, come back 32 feet, and then go back 32 feet. Okay, G. Find the acceleration at time t and after 3 seconds. I need to find the acceleration at time t and after 3 seconds. What do I have to determine? So 6t minus, yes. So the acceleration is 6t minus 24. How much is a of t? Measurement unit, careful. Good. Final question here. When is the particle speeding up? When is it slowing down? Now this is an important table. I know, me and my tables. So slowing down, speeding up. Okay. So I have t 0 to 6, 3, 8. V of t, A of t, decision. The velocity is 0 here and here. Positive, negative, positive. And the acceleration is 0, not at 3, but at 4, sorry. So A of t equals 0 means 6t minus 24 equals 0, so t equals 4 seconds. Tell me the sign of the acceleration when you plug in 0, a number to the left of 4. What is the sign of the acceleration? When I plug in 0, negative. And when I plug in 8, 48, yes. Okay, perfect. So let's analyze this. Between 0 and 2, the velocity is positive, but the acceleration pulls the particle back. So the velocity is positive, but the acceleration works against it. Two forces are working against each other. Velocity, acceleration. What does the particle do? Exactly. Slowing down. Okay, between 2 and 4, the velocity is negative, but also the acceleration. They are helping each other going in the same direction. It's like I ride my bike and there is a backwind. It increases my speed. So what happens between 2 and 4? Speeding up. Between 4 and 6, the velocity is going in one direction and the acceleration in the other direction. They are working against each other. So what happens between 4 and 6? Slowing down. Finally, between 6 and 8, the velocity is positive, the acceleration is positive, they are helping one another. Accelerating or speeding up. Any questions? Any questions? Do you think that we have the idea now on motion problems, marginal cost, determining the rate of change of volume with respect to time? So these are some applications of differentiation rules and analyzing the derivative. In this case, we analyzed actually two derivatives. The first derivative and the second derivative, to decide whether the particle is slowing down or speeding up. And also here, this was a total distance. We had to use absolute value. Why? Because we had to make sure that we're adding even the distance even when the particle was moving in a negative direction. Any questions? Any questions? Of course, the next section is also applications, the same type of idea, but derivatives and talking about or using the differentiation rules and coming up with answers. But it's a different concept. Do you want us to start? Still the same idea, word problems, applications. Yes? I know it's very warm in here. I don't want you to fall asleep. So you want me to stop for a moment and work on a problem on your own, and then we start 3.9, or you want to start 3.9? Okay, fine. 3.9, related rates. Some sort of relationship between or among derivatives. That's all it means. Some sort of relationship among, or if there are two or more than two, three or more, among derivatives. Here's an example. I have a balloon and I pump air in the balloon. What changes? What rate of change do you think you see already? Rate of change of volume with respect to time. Surface area with respect to time. Radius with respect to time. You can even consider the diameter, but that's the same with the radius. So there are already three related rates. By pumping air in the balloon, I increase the volume, I increase the surface area, and I increase the radius of the balloon. So these are related. How? I don't know. I have to calculate. But they are related. They don't just happen haphazardly, right? One goes away on a tangent and the other one changes. No. Not only do they happen at the same time, but they have some sort of relation that connects all three. We may not look at all three, we may only look at two. I don't have to look at all of them. I can look at the radius and the volume. I may want to relate the surface area or not, or I may just relate the surface area to the volume. Who knows? So in these problems, number one, we have to read the problem carefully. If we do not, number two, if we cannot create an equation that connects these rates for the variables in the problem, in this case, in my example, the surface area or the volume and the radius, I have to create an equation that has in it the radius and the volume, then I will not be able to determine how they relate to each other. So number one, I read the problem carefully. Number two, I have to come up with an equation. Number three, I have to differentiate implicitly, of course. And then I have to answer a question. That's it. However, some problems are not very straightforward. They require a lot of work. Others are quite straightforward and interesting. But others, of course. Okay, so let's see what we want to start with. We can start with 16. Let's read it and see if we're interested in talking about it. A spotlight on the ground shines on a wall 12 meters away. So imagine that there's a spotlight here and it shines onto that wall somewhere on that whiteboard. Okay. 12 meters away. Okay. If a person 2 meters tall walks from the spotlight towards the building. So here is the spotlight right here, shining onto the wall, and I walk towards the wall. Imagine the shadow, right? So it says, how fast is the length of his shadow on the building decreasing when he is 4 meters from the building? So the spotlight is here. I walk away. Here is the shadow, because of the light behind me, there's a shadow on the wall, right? But the closer I get to the wall, the smaller the shadow becomes. So it decreases. So it's going to be a negative rate. So when I'm very close, my shadow is big on the wall. But I'm getting closer and closer to the wall, so my shadow gets smaller and smaller. Smaller and smaller, and now it's exactly as tall as I am. Okay, how fast is the shadow decreasing when he is 4 meters from the building? You want to talk about it? Okay. I know it's a lot, so we'll see. We can stop after this one, and we can just look at just one taste of one problem. So this is, what was it, a 16 on 248. I don't know how to draw a person. My apologies. I just want to show you what happens here. Same height. Right? So initially when the person is quite close to the flashlight or whatever that is, a spotlight, whatever, obviously the shadow on the wall is this. As the person moves away from the spotlight, now the shadow becomes this. I don't have this. I don't have any idea what this is. I'm going to call it X. Before we even talk about anything, what is the question here? What am I asked to determine? Before I put in all the numbers and stuff, what am I asked to determine?
How fast the shadow shrinks.
Correct. Which means Find the x over dt. Excellent. This is what I'm asked. We have to go back and read the problem one more time, of course, and we have to put in the numbers and fill in everything and see how we proceed. But this is the question, right? I walk away from the flashlight, so the shadow is x tall. So when I'm 4 meters away from, and continue to walk towards the wall, when I'm 4 meters away, the shadow is still changing in length, so I want dx over dt. When it says, when the person is 4 meters away from the building. Okay, I'm not going to write this or use it at this point, but I'm going to make myself a note. When 4 meters from the wall. So basically, I'm going to determine a function that I will evaluate for some value and get a number. So I walk away from the flashlight over the wall, and at some point in time, I'm 4 meters away from the wall. I want to determine that instantaneous rate of change of the shadow on the wall, which will be in feet per second, right? Feet per, yes, meters per second. Okay, let's read the problem one more time. A spotlight on the ground shines on the wall 12 meters away. Important piece of information. So this is 12 meters. If a man 2 meters tall, okay, this is 2. And walks on the spotlight towards the building at a speed of 1.6 meters per second. This is crucial. I need to identify what this means. So I start here. Here's the flashlight or spotlight, and I walk at 1.6 meters per second. What does that mean? What does 1.6 represent? It has to be a rate of change. So I want you to give me something at the top and something at the bottom. Right, but I cannot use x because x is here. Excellent. So I'm going to say that this is y. I'm going to say dy over dt. Awesome, right? So I cannot use x. I have to use a different letter because x is over there and y is over here. So I'm walking, this is the rate of change. So this changes the rate of change of y with respect to time. 1.6 meters per second. That's the rate of change. Great job. How fast is the length of the shadow of the building decreasing when he is 4 meters from the building? So here. Is this, if this eventually, this is 4 meters. How many meters did he walk?
8.
Yes, thank you. 8 meters. So I'm really asked to evaluate dx over dt exactly for x, for when x is 8. So this is the question. So we're asked to find dx over dt when x is 8, and that's our question. So please say it again. Of course, thank you. Sorry. Of course. Y equals, yes, true. So y equals 8 indeed. And I want to make a note. Do not use until the very last step. You cannot put this anywhere. You cannot use it anywhere. Till the very last step, after you found the function, you differentiated it, and then you plug in y equals 8. Do not consider that in the problem. Okay, so here's what we have. what am I telling you? Well, obviously, what am I trying to do is connect X to Y. That's all I have. I don't have anything else. I have this that I cover, and I have that changes. So this rate and this rate have to be related. But I have to find a relationship between the two. So I have to find a relationship between y and x so I can differentiate and get a relationship between dy over dt and dx over dt. Is there anything that I could write based on what I just showed here, and what am I really telling you? I'm telling you that the small triangle and the big triangle, because they are both right triangles, are excellent. They are similar. So I'm going to write A, B, C, D, E. So the triangle ABC is similar to the triangle ADE. And ABC, meaning that C and D are the same. These two are the same. These two are identical. And these two are identical. That has to be the correct order. So this is the same in both triangles. This is the same in both triangles. Therefore, this must be the same in both triangles. Because they are similar, I can write proportions with their sides. I start from the common angle. The opposite side of the common angle in the small triangle. Go back to the same angle, the opposite side of angle A in the big triangle. There is no point in analyzing this because I don't have this and I don't have that, so this is not useful. But this and this, these two are congruent, equal. The opposite of this is, here's my relationship. XY equals 24. I found the relationship between the distance that I cover and the height of the shadow. Both are functions of time. This changes with time. That changes with time. There are two functions. X is not an independent variable. Y is not an independent variable. So both functions of time. So we differentiate both sides. And please tell me what to write. I have to use which rule? The product rule. First, second. Yes, the right-hand side is nice and easy. But the left-hand side must be a sum of two terms because I use the product rule. So what do I have? The first function prime, dx over dt, times the second function, plus x times the second function prime. That's why I wrote it here, because I know it's difficult to see that at the beginning. So what am I after? Good. I'm only going to solve for dy over dt, moving this to the other side. X dy over dt equals the opposite of y dx over dt. And then I'm solving for dy over dt. I'm happy now. Now, yes, this is the final step. I also have this then, which is 8. I have this that you told me a long time ago is 1.6. And now you're going to ask, what about this? No problem. If y is 8, how much is x? That's it. Why? Because xy equals 24 and y is 8. So this must be 3. So then dy over dt, when y is 8 if you want, when x is 3 if that's what you want to write, is negative 8/3 times 1.6. And I'm lazy tonight. So what do we get? 8 times 1.6 divided by 3. I got 4.3 approximately. Of course, negative 4.3 what? The rate of change of distance with respect to time.